This is video number 2 on the topic motion in a plane. Timestamps are given in the description box. You can watch parts of video if you are running short of time. In this video, I will discuss vector algebra. What will happen to your vector when it is multiplied by a real number? The real number can be positive or negative. How to add and subtract vectors. So if you take a vector and multiply by a real number, say for example, I take a vector E. The vector is represented by an arrow mark. The direction of the arrow is the direction of the vector, and the length of the vector is proportional to the magnitude of the vector. So if this is a vector, then 2a vector will have a length twice of this a vector, and the direction will be same because the direction of 2a and a are same. So if we take another vector minus a, the length of this minus a and plus a will be same because the magnitude of the vector is same, but the direction is opposite to that of e. So if you multiply a vector by a positive real number, then the direction is same as the original vector. So a and lambda a will have the same direction if lambda is positive. But if lambda is negative, then a and lambda a will be in opposite directions. Suppose if a is like this, then lambda a will be in the opposite direction. If lambda is greater than 1, then the size will increase. If lambda is a fraction between 0 and 1, then the size of the lambda a will be less than the vector a. So two scalars can be added as adding two real numbers. But how to add two vectors? Let me consider a block and say it's acted by two forces. First force is say 5 Newton. This is just an example. Second force is say 3 Newton. Then I can say this is equivalent to the block being added by a force of 8 Newton, because the effect of the two forces will add up. But suppose you reverse the direction of the second force 3 Newton and apply the force like this in the opposite direction, but the 5 Newton is like this. Then I can expect the net force to be of 2 Newton towards right. They are opposing each other, so we can expect them to subtract. But if you take a general case where the second force is not at 0 degrees or 180 degrees, but some arbitrary angle, say an angle theta, then this is equivalent to how much force? That I have to find out. So to do that, we need a rule to add the two vectors. So we use triangle law of addition to add two vectors. Here there are two vectors, A and B. So the rule says join the tail of the second vector to the head of the first vector. So tail and head should join. After that, to get the sum of these two, I'll take a vector which is joining the tail of the first vector to the head of the last vector. To remember this, I can assume this is the initial point and this is the final point. So I can go from initial point to the final point by two ways. One is along A and B, another is along R. So the end effect is same. So the vector R should be same as A vector plus B vector. So direction of A vector is like this, B vector is like this, the result of vector is like this. So given The triangle law gives the direction of the resultant vector. So this is adding two vectors. Now if you have more than two vectors, how to add them? For example, A plus B plus C plus D, four vectors I have to add. Since I know how to add two vectors using triangle law, I can add these two and get the sum. I say sum 1, and it's a vector. And I can add this sum 1 with C to get the second sum S2. And I can add this and the fourth vector D to get the final result as S3. So if you take four vectors, A, B, C, D, like the one shown in this illustration, E, B, and C, D, the relations are like this. So a vector can be moved parallelly without changing its effect. So B is moved parallelly so that the tail touches the head, like that. So here, first I'll add these two vectors to get A plus B as like this, using triangle law. Now let's take the third vector C and move it such that it touches the head of the A plus B vector. So now this plus this is this vector using triangle law, because triangle law, I'm just taking two vectors. One is A plus B and then C. Second vector is C. So this is some of the first three vectors. To add the fourth vector, I can move it parallelly so that the tail touches the head of the A plus B plus C vector. And I have to join the tail of the first vector to the head of the second vector to get the resultant. Here also I can remember this as this is the initial point and this is the final point. I can go to the initial point and the final point by two ways. One is along A, B, C, and D. Another is along R. So effectively both should be same. So R should be same as A plus B plus C plus D. So this gives a Polygon law of addition, which says if you have to add n vectors, join the vectors head to tail one by one, and the tail of the first vector to the head of the last vector is the sum of the n vectors. So from triangle law, I can get the Polygon law like this. Head of the first vector should be joined to the tail of the second vector, and head of second vector the tail of the vector, and so on. So result is the sum. Resultant vector is a vector from the tail of the first vector to the head of the nth vector. So this polygon will have n plus 1 sides. Like triangles are adding two vectors, it will have three sides. Similarly, for adding n vectors, I will have a polygon of sides n plus 1 side. And one more thing is, in this particular illustration, I have taken these vectors to lie in the plane of the board. That's not required. The C vector can be like this. Then also I can move it parallelly. So this will be like a distorted polygon. I can just pull out some vectors so that it comes from the plane of the board, but still this law is valid. So this law is also valid for vectors which are not coplanar. We just have to join head and tail of the vectors to form a distorted polygon and then complete the polygon using the n plus 1 side. The n plus 1 side is the sum of the n vectors. Similar to triangle law, we can also have parallelogram law of addition of two vectors. Here the two vectors are A and B. In triangle law, we made head and tail join together, but in parallelogram law, we make the tails join together. So tail of the two vectors are touching here. So we have to complete the parallelogram with A and B as the sides of the parallelogram. So draw a line parallel to this A vector and draw a second line parallel to this B vector which touches this head of this A vector and complete the parallelogram. So the diagonal of the parallelogram which is between this A and B is the resultant. This is equal to triangle law because this vector and this vector are same because they are parallel and the length is same. In parallelogram, the opposite sides are of equal length. So from triangle law, I can get this vector as this plus this. So triangle law and parallelogram law are equivalent. We can solve some simple questions to get an understanding of vector addition. Given two vectors of magnitude 3 and 4 with their directions not fixed, what is the maximum and minimum magnitude of the resultant? So two vectors, first vector let me take it horizontal of magnitude 4, and the second vector, the direction is not fixed. To start, let me take this as the direction of the vector 3. Okay, so this angle theta is variable. So one extreme case is 4 is like this, and the second vector is also like this. So then in this case, the resultant will be a vector of length 7. Another extreme case is 4 is towards right, but 3 is opposing it in the opposite direction. So here the resultant will be 1 towards right. So for any other arbitrary angle like this, it will be between 1 and 7. So the interesting thing to note is the resultant vector will be between a particular range, which is between the maximum and minimum. Maximum means both are in the same direction. Minimum is when they are anti-parallel. So it will be between 1 and 7. But suppose you make a mistake and get a value which is beyond this range, we can figure out that there is some mistake in the calculation. Next question, given two vectors of magnitude A and B, directions not fixed, what is the range of values the angle between them can take? So two vectors, A, B, let it be a longer vector. Okay, the angle theta between them. So theta, B, if it is like this, theta is 0. So theta can be between 0 degrees and B can also be like this, 180 degrees. If it is greater than 180 degrees, for example, B can also be like this. In that case, instead of saying the angle between the two A and B is like this much, I can say the angle is the shorter angle this much. So that way I can restrict the angle between the two vectors between 0 and 180. It's not necessary to make it more than 180 because I'll take the shorter angle. What is the set of n vectors which form a closed polygon? So the n vectors may move parallel, say first vector, second vector, so on. But when I draw the nth vector, it's forming lines. So this is the nth vector. First vector, second vector, third, so on, nth vector. Then according to Polygon law of addition, I have to take the tail of the first vector, the head of the last vector, and join these two. This is a vector of length 0. So the result of vector is 0 vector. So sum of n vectors which form a closed polygon, the sum is 0. This is true even for a non-coplanar polygon. So negative of a vector is take the vector and just reverse the direction. So this is a vector, say k. To get the negative of this vector, just reverse its direction. So head will become tail and tail will become head. So this is minus k vector. It's by multiplying by lambda, where lambda is minus 1. parallel transfer of vector. As I said, for adding vectors, I can say this is A vector and this is B vector. So to apply the triangular omega, head and tail touch each other. So I'm transporting this vector parallelly here. It should be parallel like this. Then I can add these two. So if I'm able to transport this vector parallelly without changing the effect, then it's called a free vector. But certain vectors, this transfer of vector is not, the effect will be different. For example, if I take a rod which is fixed here and the force E is applied here, okay, and force B is applied at this point. I'll take a bit. Okay, let me take a rod which is fixed in the middle. Okay, and second vector B is here. Okay, here okay, suppose I keep this vector B here, then the thing will rotate in anti-clockwise direction because of the force of the B vector. But same B vector, if I transfer it here, then it will try to rotate the rod in the clockwise direction. So here, B vector, it's not a free vector because if I transport it, the effect is different. So it's not always possible for a vector to be transported parallelly without changing the effect. So such vector is called localized vector. So if we can add two vectors, similarly we can subtract two vectors because subtraction of two vectors, say P and Q, P minus Q, I can think as this is equal to P plus minus Q. I know how to get minus Q vector, I just have to reverse the direction of Q vector. So since I know how to add two vectors using this one, I know how to subtract two vectors. So P minus Q is equal to P plus minus Q. Minus Q is just reverse the direction. I am transferring this vector because it's a free vector. So I can use a parallelogram law to get this sum as this one, resultant as this one. Or I can use a triangle law, minus Q transported parallelly. Here, so the head and tail touch each other. Using triangle law or parallelogram law, I can get P minus Q as this resultant vector. So I know how to subtract vectors because I know how to add the vector and the negative of the second vector. Consider this question. Let the two vectors A and B be adjacent sides of parallelogram and the tails join together. What do the two diagonals correspond to? So by using parallelogram law, I can see this diagonal, which is between the two vectors, is A plus B. And the second diagonal it's between, the direction is given like this, so it's between this vector and this vector. So this vector is A. So this vector, if I reverse the direction, it will be minus B. This vector from here to here, it's minus B. So this diagonal is between A and minus B. So this vector is A minus B. So one diagonal is A plus B, and the other diagonal is the difference of the two vectors, A minus B. You can ask the doubts in the comment section.